All right, in this section we're looking at the half-angle formulas. We have one for sine and one for cosine, and then we've got these three different formulas for tangent. So these are given in the terms of, sine of half an angle, right? Sine of alpha over 2. And depending on what quadrant the angle is in, when you find sine or cosine of half that angle, it could change the sign, which is why there's a plus or minus in front of these radicals. So in our text, they use the identities that look like this. Sometimes I kind of think of them as, I'm going to just take the sine version, for example, and rewrite it up here. If you square both sides, then on the left side you get sine squared of alpha over 2 equals, and then when you square on the right side, you're going to square the square root, so it gets rid of the radical, but also regardless of whether it's positive or negative here, when you square it, it'll be positive. So sine squared of alpha over 2 is 1 minus cosine alpha all over 2. And this is the version of half-angle identities that I often see sometimes in other books. So our text uses the one with the radicals and the plus or minus, but you might see them written in this form up here. In other spots. So we're going to do some examples. We're going to start by simplifying this expression. It kind of vaguely, like this radical, vaguely kind of takes on the appearance of one of these first two formulas on the left side here. Notice that the difference between the half angle for sine and the half angle for cosine is really just whether we're adding or subtracting up here in the numerator. So because of this addition, I'm thinking probably it's going to shake out to look something like this half angle for cosine. I'm going to start, of course we have this factor of 9, I'm going to start by factoring out a 9 up there. Now I have a factor of 9 inside this radical, so I can bring that outside the radical. That comes out as a 3, right? The square root of 9 is 3. So now we have 3 times the radical, 1 plus cosine 6x all over 2. And now this really does look like this form up here, where alpha is 6x. And so if I use this identity in the right to left direction, now I've got 3 times cosine of 6x over 2, or 3 times cosine of 3x. Okay, let's do another one. We're going to prove that this radical expression on the left is equal to 2 times sine of 1/2 alpha. So certainly I'm going to start on the left side just because there's more, it looks like we have more options available to us. I'm going to just kind of note that on the right side we have sine of 1/2 alpha. So somewhere I'm going to be looking for being able to use or recognize the half-angle identity for alpha, for sine rather. Right, so I'm gonna be on the lookout for seeing something that involves a radical, either plus or minus a radical of 1 minus cosine alpha over 2. So I'm just making a note right there that at some point, if it shakes out where I see that expression, I'm going to be able to use the half-angle identity for sine to be able to maybe finish up the problem. But let's start on the beginning this problem. I'm going to work on the left side. And I'm going to do kind of the only thing that comes to mind here, which is that I can square out the 1 minus cosine alpha. If you FOIL this out, then you'll get 1 minus 2 cosine alpha plus cosine squared alpha, and then we have plus sine squared alpha. Looking at this expression, now focus on this part here. Sine squared alpha, cosine squared alpha plus sine squared alpha. That's the Pythagorean identity. This is equal to 1. So I've got that. I've got a term of 1 here. I'm going to combine it with the one that we have in the beginning. So I've got the square root of 2 minus 2 cosine alpha. Okay, So this is actually looking not so bad right now. I've got that radical. I'm still not quite at a spot where I can use the half angle identity for sine. You know, we want a fraction, first of all, in there. We want a fraction that has a denominator of 2. Right now, if I see this as a fraction, and we can, inside I have a denominator of 1. So I'm going to multiply the fraction that's inside the radical by 2 on the top and the bottom. So on top I have 4 minus 4 cosine alpha all over 2. I have a common factor of 4 now, so I'm going to take that out. 1 minus cosine alpha over 2. If I have a factor of 4 inside the radical, I could take it out. It becomes a 2 outside the radical. So this is 2 times the radical 1 minus cosine alpha over 2, and there is the right side of the half angle identity for cosine that we were talking about in the very beginning. So that is cosine of alpha over 2. So this is 2 times cosine, that is sine of alpha over 2. So we have 2 times sine of alpha over 2, or 1/2 alpha. And that's what we wanted. Let's do another one. We're going to show that 2 times cosine squared of x over 2 minus cosine x is equal to 1. I think it's pretty clear that we're going to start on the left side because there's not a whole lot we're going to do on the right side. So I got 2 times cosine squared of x over 2 minus cosine x. So I've got a cosine of x over 2 and we're squaring the whole thing. I'm going to kind of write this out in a couple of steps, but basically I've got a factor of 2, then I have cosine of x over 2 that we're squaring, minus cosine x. Cosine of x over 2 is plus or minus, if I use the identity on the last page, plus or minus the square root of 1 plus cosine x over 2. We're squaring that. If I square that, I'm going to get rid of the radical and get rid of the plus or minus, because regardless of what sign it is, when we square it, it'll be positive. So we have 2 times 1 plus cosine x over 2, and then minus cosine x on this product that we have at the beginning. This 2 and the 2 in the bottom will cancel. So we have now 1 plus cosine x minus cosine x, and of course plus cosine x minus cosine x cancel out, and we're just left with 1, and that's what we wanted. Success. Okay. To finish out this section, we're going to derive an expression for secant alpha over 2 in terms of cosine alpha. Well, if we, to start out, right, we have secant alpha over 2. We want to get an expression that's cosine alpha. If they didn't specify cosine alpha and they just said the cosine function, it would be really simple, because I would just say, okay, well, secant alpha over 2 is 1 over cosine alpha over 2, and there's our cosine function, and we could be done with it. However, that's cosine alpha over 2, and we wanted cosine alpha. So I've got cosine alpha over 2 in the bottom, so I'm going to use the half angle identity there. If you look on the first page of this section, this will be plus or minus the square root of 1 plus cosine alpha over 2. Now I've got a fraction inside a radical. We can split up that radical over division, so we've got the square root of 1 plus cosine alpha over the square root of 2. And now I'm dividing by a fraction. And dividing by a fraction is the same as multiplying by its reciprocal, so instead of 1 divided by that fraction, I'm going to have 1 times plus or minus root 2 over root 1 plus cosine alpha. And so we have plus or minus the quotient of these two radicals. Now we can combine the radicals over division again. So plus or minus square root of 2 over 1 plus cosine alpha. And there's our expression for secant of alpha over 2 that in terms of cosine alpha.